The point of gathering data and using statistics is to answer questions about the real world, like does a medicine cure people? Or does going to preschool reduce crime rates later in life? Or how good are US versus Chinese students in math? That kind of thing. This data can come either from an experiment or an observational study. So let's talk about what those two things are for a bit. So an observational study just means that we're going to observe and measure individuals without changing what happens to them. So, for example, we might survey 10th and 11th graders at the end of the year about how much bullying there is at Wilson Prep. We aren't changing anything about them, we're just gathering data based on their experiences. There's just one problem with this. It is very difficult to determine what causes any differences that you observe between groups. So for example, we might observe that students who read more tend to have higher SRI scores. But the thing is that we don't necessarily know why that is. Difficult. And in this case, there are several possible answers. So, for example, maybe students who are good at reading, so just these are some possibilities. Maybe it's the case that students who are good at reading like it more, and so do more of it. So in that case, higher SRI scores cause students to like it more, cause them to do more. Maybe it's students who read more get better at reading. As measured by SRI scores. Maybe there is something else entirely that's causing both of them. Maybe someone who has a strict advisor both has to read more because their advisor makes them, and also makes them try harder on the SRI score because they're going to get grilled on it at their student-led conference. So although observational studies are sometimes the only thing that we can do, so for example, if we're studying differences between countries, we don't have the power to go and make, people in Venezuela or wherever do something different. We can only observe what's been done and compare it to some other country. Sometimes observational studies are all that we can do, but the problem is that it's very, very, very difficult to determine cause and effect based on observational study. So that leads us to experiments, which are another way of gathering data that we can use to try to determine cause and effect. And in an experiment, we're going to deliberately change individuals' experiences to see what the impact is. So, for example, we can make students read in advisory during OTTR and see if their SRI scores go up. This change that we make, so in this case making someone read, in other cases it might be giving someone a medicine, it might be sending young children to preschool, whatever it is, that change that we make is called the treatment. And there's a nice vocab word right there. So the thing is that we can totally do this. In fact, we did as a school. Okay, students, everybody's going to be reading in advisory every other Monday. But the problem is, how do we know that the treatment really caused the change? After all, even without OTTR, we see SRI scores generally go up every year, just as part of getting older, as a part of doing the work that we do in school. So if I say in my advisory, okay, everybody, you have to read, and I'm going to measure your SRI scores at the beginning and the end of the year, well, how do I know that that change was actually due to the OTTR program? And that's true just in general in experiments. It's great. Somebody got better because after I gave them whatever medication it is that we're doing drug tests on. Well, how do I know they didn't just get better on their own? So the solution to this is to compare the treatment group who got the treatment to what's called a control group. Who did not. That's a good vocab word, control group, right there. And so, for example, maybe we could make half of the advisories read and half of them not read, and then compare which group grew more in their SRI scores. The key with this is if the treatment group and the control group are the same, except for this one thing that's different about them, then that thing that's different must be what caused the differences that we measure at the end. So the way that it works is you would start off with your subjects or your participants in your study. So in the reading case, it might be students at the school. And then you're going to divide them into two groups. These would be randomly chosen. We'll talk about that in a second. And one group is the treatment group. And one group is the control group. And the treatment group, in this case, gets the treatment. So in this example, the study participants would be students, and the treatment group would be made to read. The control group does not. Does not get the treatment, so don't have to read. And then over here, compare outcomes. So what this would be is we would measure and compare SRI scores. There are a couple of really important points here whenever doing an experiment. One is that the control group and the treatment group need to be as close to identical as possible if we can at first. Because the thing is, if the treatment group and the control group are different in some other way, so let's say we are making all the middle schoolers read and not making the high schoolers read, then we don't know if the differences in SRI scores at the end are due to one group reading and one group not, or if they're due to one group being middle school students and one group being high school students, because we'd expect to see a difference there. And similarly, if there's some other thing that's different, if we're testing whether or not a drug works, well, maybe that's the thing that caused the difference in whether or not people got healthy. So typically the way that we do this is we randomly pick which group each person is in. It can be flipping a coin. When I was an undergraduate student, I helped with a psychology research lab, and that was how we did it. When someone came in the door, we just flipped a coin, and we either put them in the treatment group or the control group that way. Or using a random number generator. There are other ways to go about trying to match the treatment and control group. There are more sophisticated methods, but the basic one is just pick a random number, randomly assign them to each group. The thing is that it's very, very difficult for human beings to not have some sort of bias when they're sorting people on their own. So that's why we typically use random numbers. They're just a little more objective. Another important point, if possible, participants shouldn't know what group they're in. So if person's in a control group, they ought to think they're in the treatment group. Basically, everybody should be thinking they're in the treatment group. And the reason for this is something called the placebo effect. Really great vocab word. A placebo is basically just a fake treatment. When people believe they're receiving a treatment, they'll respond even if they really didn't get anything. So for example, when testing new drugs, new medications, simply giving someone a pill and telling them they're getting an experimental treatment, they will oftentimes get better, even if the pill is fake. There's actually nothing in it at all. And that fake pill is called a placebo. And so the placebo effect is people getting better simply because they think they're being treated. And so to try to minimize this, experiments try to make the two groups' experiences as identical as possible. So we talked about fake pills, if it's a medicine. If it's something like testing the effect of counseling, then one group will get the particular type of counseling that they're experimenting with, but the other person is going to have someone come in and spend time with them too. They just won't get that specific technique. In the example of the trying to test if otter works with the reading, maybe the control group would also have to sit quietly for 15 to 20 minutes in advisory, but maybe they would be drawing instead of reading. The goal is to make the two groups' experiences as identical as possible. Because remember, the thing is that if any difference between the two groups could be what's causing the differences at the end. So for example, when testing therapy, maybe it's not that the actual therapy program is worth anything. It's just the fact that the people who were in the program had someone come sit and talk to them. Maybe that was the only thing that really mattered. So if the control group had just been sitting by themselves, well, that's a difference between the two groups. If the treatment group is spending time talking with someone for therapy, that's a difference between the two groups that could be causing the difference at the end. And a third thing that's really common is that many experiments are what is called double-blind. And what double-blind means is simply that the researcher measuring the results doesn't know who's in each group. And the point of this is for things that are subjective, like how healthy someone is, or how happy someone seems. If the researchers know that they're talking to someone who's in the treatment group versus the control group, then they may bias their own measurements, their own evaluation of the person. Double-blind experiments aren't really used if you're like studying plants or something, because the plants, it's pretty objective. You measure how tall they are, you measure how many leaves they have. If the measurements are really objective, then experiments don't need to be quite so double-blind. But if there's any subjectivity at all in measuring those outcomes, then it's important for experiments to be done, such that the researcher doesn't know which treatment group it is, or which person's in the treatment group. Okay, let's do a quick example, and then we'll be all done. So for each of these, does each scenario, does it describe an experiment or an observational study? So for our first scenario, researchers find whale calves that were born in the Caribbean versus were born in the warm waters of the volcanic islands. They're just going to compare their size. Leave just a little bit of space there. In the second scenario, researchers change the water temperature for half the orcas in SeaWorld. And compare how active they are, the orcas that is. So what we want to figure out is, are each of these an experiment or an observational study? And remember, the difference is that for an observational study, we're just observing and measuring individuals without changing what happens to them. Whereas in an experiment, we're deliberately changing the experiences of the participants. So here, researchers just find the whale calves that were born, and they just measure them and compare them. They don't do anything to change the animal's experiences. So this would be an observational study. Whereas here, the researchers deliberately go in and they change something. They change the water temperature for half the orcas and compare the activity levels of the two orcas. So because of that change, that would be an experiment.